Today we're going to start with 25.5, the assignment, and the directions say, given f of x equals 2x plus 1 over 2x minus 1, answer the following questions. So part A, use a graphing utility to graph f of x. So graph it, and I'm going to sketch that graph in my notes, so go ahead and sketch it in yours as well. And then we can answer questions.
Yes, because you multiplied. Because I had and you expanded and oh wait, no, she didn't expand and she looked at it today, so then that's negative 4.
Okay, have y'all got it in your graphing calculators?
Yes.
So there it is in our graphing calculator, and we can sketch that in our notes. So the first question said, find the zeros of f of x. So looking at your graphing calculator, what is the zero?
Negative 0.5.
Negative 0.5 or negative 1/2 0. And then now C says calculate f prime of x. And we can use the quotient rule. Has anyone gone through it and gotten an answer?
Well, we got the same thing. We're at the same step, but...
Okay, and so how does the quotient rule start?
So it's g times f prime minus f times g prime, and then all over g squared.
Good. So 2x minus 1 times what?
2.
Because it's low d high. Remember I said just remember low d high. Low d high, and the derivative of the top is 2 minus
2
high d low, right? And I always do double parentheses. So 2x plus 1 times 2 all over low squared. Low d high minus high d low. Okay, and now simplifying the top, we have 4x minus 2, and then this is 4x plus 2, and so it becomes a negative and a negative, so a minus 4x minus 2 over the bottom squared, which simplifies down to what?
Negative 4 over 2x minus 1 squared.
Good. So that is our derivative
Very good.
of f of x.
Wait, I'm confused on why you don't FOIL it out. Like, why do you stop there?
You can, but you're more likely to make a mistake if you keep going. So we've answered the question, so I'm just going to leave it like that, and that's acceptable. And there are times when you could leave it like our very first step. Low d high minus high d low over low squared.
So this is one of those ones that there's like tons of different ways you can answer it. Just leave it as
If it's
simple.
and if you're using the derivative though to plug in values and answer a question, you would want to get to this step right here, because you're only having to plug in one value and then simplify negative 4 over that number squared.
Okay.
So would these questions be multiple choice then? Since there's
You could have it at either multiple choice or free response, to where you would have to use the quotient rule to find the derivative. So free response, less simplifying, less likely to make a mistake.
Okay.
Multiple choice, it's going to be completely simplified.
Yeah.
Okay, and then D said, determine those points where f of x has a horizontal tangent. So if we look at the graphing calculator, what am I looking for when I'm looking for a horizontal tangent?
0.
Of derivative of 0. This is f of x. Am I going to have any horizontal tangents? I'm looking for, does it ever go from increasing to decreasing or decreasing to increasing? This curve right here is always decreasing. This curve is also always decreasing, so is it ever going to have any horizontal tangents? No. How can I justify that?
No max or mins.
There's none. It said determine those points where f of x has a horizontal tangent, there's none. So to justify it, we could say using f of x, there's no max or mins because the function's always decreasing. F of x is always decreasing. And then what could we say about the derivative? F prime of x, f prime of x, the horizontal tangents
Always.
are the zeros on the derivative.
And there's no zeros.
There's no zeros. So f prime of x does not equal 0. So let's go look at that function. Because I'm curious. Does it have zeros? So y equals, watch it, I'll put 4 over 2x, is it plus or minus? Minus. 2x minus 1 squared.
Oh, it's a negative 4.
Oh, it's a negative 4.
Yes, ma'am.
Thank you. And now graph it. What happened?
The
I
4
put a
didn't.
minus on. Oh, I forgot the 4. There. So there's f of x. And now here is and why doesn't it have any zeros?
Because the function is always decreasing? Or,
The
The slope never equals
Slope.
0.
this line y equals 0 is the what for this function? The
Oh.
derivative.
horizontal.
A horizontal asymptote. The degree is bigger on bottom,
Oh,
which
so-
means that horizontal asymptote is y equals 0, so that's why the derivative has no zeros. Alright, E says write the equation of the line tangent to the graph of f of x at the point where x equals 1. So I'm writing the equation of the tangent line, so I know I need y minus y1 equal to m times x minus x1. I know I need my point. And they gave me the x value, so what is the x value in my point? 1. And so now I need f of 1. And then I need my slope at 1, so I need to find out what is f prime of 1. Alright, so if we plug 1 into the original function, f of 1 will equal 2 plus 1 over 2 minus 1, which is equal to 3. So there's my point. And now f prime of 1, plugging it in to negative 4 over 2 times 1 will still be 2, minus 1 squared. So do you see why it's more convenient here to have the simplified answer?
Mm-hmm. So you only have to plug it in once and you're done.
Yes, so my slope is negative 4. So now putting it all together, my equation of my tangent line is y minus 3 equal to negative 4 times x minus 1. And now, F, the last question, let me pull the document back up for y'all to reread it. And this is a new question, so new concept. F, a normal line is perpendicular to a tangent line at a given point. Write the equation of the normal line to the graph of f of x at the point where x equals 1. So we know how to write a tangent line. Now it's asking us to write a normal line. And it tells us the normal line is perpendicular to a tangent line at a given point. And what do we know about perpendicular lines?
They have opposite.
They have opposite reciprocal slopes. So remember, if you have opposite reciprocal slopes, that means you change the sign of the slope and you flip the fraction. So everything stays the same when we write the normal line, except we need an opposite reciprocal slope. So opposite reciprocal slope is the only change when writing the equation of the normal line. So if the equation of the tangent line has a slope of -4, then the normal line has a slope of +1/4. And then since it's still at x equals 1, everything stays the same. So it would be y minus 3 equal to 1/4 times x minus 1. That is the normal line equation. So the only change of a normal line to a tangent line is its slope is the opposite reciprocal. Alright, so there are, on A 25.5, there's still questions 2 through 5 using the product and quotient rule. So make sure y'all finish that assignment. Before we move on, I want to show you how to find the derivative, how to check it in your calculator. So the graphing calculator will actually graph the derivative of a function. So if you're ever not sure, you have an odd equation, this is a way you can check yourself on your homework. So in y1 I have the function, in y2 I put my answer to the derivative, so I'm now in y3 going to ask my calculator to graph the derivative, and I know it should match up with what I put in y2. So we go to math, and then number 8 is the derivative, math number 8. And then we have the notation, so it's the derivative d over dx because it's with respect to x. I want to take the derivative of my function in y1, so I'm going to put y1 in parentheses. So remember, you can go to bars, over to y bars, and then number 1 for function, and then there's y1. So do I need to go through that again?
Yes.
Okay.
Bars, okay.
So to get y1, we go to bars, over to y bars, which y variable, and then we're looking at functions, so number 1, and there it is. So bars, y bars, function, and there's all your equations. We want the derivative with respect to x of y1, and we want it for all x values, so x equals x. And then once you have that in and you hit graph, we'll see we have the correct derivative. So math number 8 allows you to graph the derivative of a function. And so, on free response questions, or even multiple choice questions that you are allowed a graphing calculator, that's a nice feature to use if you have a question about the derivative. Where are the zeros of the derivative? If I know I get to use my calculator, I can go graph the function, graph the derivative, and find where the zeros are. And we haven't used calculators yet, but we will start using them. Okay, so topic 26. We'll start it, but we won't finish it. Alright, so topic 26. Zoom out. Topic 26 is over linear approximations. And derivatives of absolute value and piecewise functions. So you have a quick derivative quiz tomorrow, and it will not take long at all.
Just go over like the rules and.
It's over, let me double check. Let me double check real quick to make sure. I believe it's over only powered constants. But I need to double check myself.
So it's just the easy one.
So it's, yes.
Yeah.
So, yeah, it's a quick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions, so the derivative quiz tomorrow is just 10 questions. Product and quotient are not on it, only constant and power rules.
Okay.
So it's a quick quiz, probably 10 minutes, so we will finish this lesson tomorrow, what we don't do today. We'll do about 10 minutes, and then it'll be time to go. Okay, so first, describe the tangent lines of each function as above or below f of x. Okay, so my first tangent line will be right here. And then also on when it's concave up, increasing right here. And my tangent lines, where are they? Above or below f of x? Below, so below f of x. And then when it's concave down, where are the tangent lines? Above or below f of x? Above. And so we use this concept when we're finding linear approximations. So linear approximations is the use of the tangent line at a point, we'll say A, f of A, to the curve, y equals f of x, when x is near a. So it'll make more sense as we do an example. So example number 1. And this is all we'll have time to do today. F of x is equal to x squared times 4x plus 1. And part A, use linear approximation to find the value of f of 2.97. So notice that in order to find f of 2.97, that's going to be hard to do because it's an odd decimal. So we have to use a linear approximation, so we can choose the x value of 3. And now we know f of 3 will equal 3 squared times 4 times 3 plus 1, which will be 9 times 13, which is 117. And then now we're going to use the derivative to finish the process of finding f of 2.97. So right now I currently just have, I know there's this point 3, 1, 17. And if I go back to my definition of what a linear approximation is, it's the use of the tangent line at a, f of a, as an approximation to the curve y equals f of x when x is near a. So I've got my point. It says it's the use of the tangent line. What else am I going to need if I'm using the tangent line? The slope. So that's why we need the derivative. So f prime of x, we could distribute this and it'd be easier to use the constant and power rule. It becomes 4x cubed plus x squared. And so f prime of x is 12x squared plus 2x. And so f prime of 3, if I plug in 3, 12 times 3 squared plus 2 times 3 gives us 114. So now I can write the equation of the tangent line at x equals 3. So equation of tangent line at x equals 3 will be y minus 117 equal to 114 times x minus 3. And then if I solve that for y, I know y will equal 114 times x minus 3 plus 117. And so this is a function. It's a linear function because it's the tangent line at x equals 3. So if I plug in 2.97, that's going to give me approximation of where the tangent line for f of 2.97 is. And we'll look at the graph to help tie this all back together. So f of 2.97 from the equation of the tangent line will give me 114 times 2.97 minus 3 plus 117 which with a calculator that is approximately 113.580. Okay, so I hate leaving y'all on a cliffhanger, but I want to explain this in detail tomorrow in class, okay? So we're going to stop here. We've gone through and found f of 2.97 with the linear approximation. We'll finish this tomorrow.